Alright, today we'll be talking about the Polygon-Angle sum theorem and all the cool things you can do with it. But first off, we got to get some definitions. Equal angular polygon has all equal angles. Okay. An equilateral polygon has all equal sides. Oh, excuse me. Alright, and a regular polygon has both. All equal angles and all equal sides. Okay, and we'll be dealing with a lot of equal angles and stuff. Or regular polygons, because that's some really cool, there's some really cool formulas that can come from it, that you can find the measurements of a regular polygon, like for example the area, just by using two numbers, a thing called an apothem and perimeter. So it's really kind of cool. Alright, but the Polygon angle sum theorem states this. The sum of the interior angles in a convex polygon is the number of sides n minus 2 times 180 degrees. Okay, alright, so the number of sides you do need to know. Alright, now convex, there are two types of polygons, convex and concave. Convex is where there's really no entrance into it. Convex is right there. So something that looks like this. Okay, whereas concave actually has what I like to call a dent in it. Okay. Some people would say, oh, you know, it looks like it kind of has a cave, so therefore it's concave. Yes. Okay, concave we're not going to be dealing with as much. Convex is probably what we'll be dealing with quite a bit in here. Okay, so let's say, for example, the sum of interior angles in a convex polygon is that many degrees times the number of sides minus 2. Okay, so find the sum of the interior angles in a hexagon. Okay, so a hexagon has 6 sides. 1, 2, yep, there we go. We got the 3 right there. Alright, so what is the sum of all the angles? So the angle sum would be 6 minus 2 times 180 degrees. Okay, which should be 4 times 180, which, if my calculation serves me correct, 4 times 180 is 720 degrees. Now, do I know anything about those angles? No, but I do know that they all add up to 720 degrees. Now, why does it work that way? Here's a cool thing. Okay, everyone can agree that the sum of the interior angles inside of a triangle is 180. Well, if I go from one vertex to all the other vertices, I can make not just one triangle, not just 2, not just 3, but I can, with a hexagon, I can make 4 triangles. And if you notice, those number of triangles and this number 4, they don't seem to be very incidental that they happen. So if the sum of all the angles inside of here is 180, here 180, and here 180, and here 180, that seems to line up pretty good with it. So if you forget this theorem, draw your shape, whatever shape you're dealing with. So in this case, a hexagon has 6 sides. Okay, draw it. Then draw how many triangles you can get from one vertex. Okay, and then that number of triangles that you can get, times that by 180, because each one's 180 degrees inside, and you have the sum of all the angles inside of the regular shape. Okay? Alright, now conversely, we can also go backwards. If we know the sum of all the angles is going to be 3,240 degrees. Okay, oops. How do we find out what the actual answer, how many sides there are? So you set up 3240 equal to n minus 2 times 180. Okay, you divide both sides by 180. So 3240 divided by 180 is 18. 18 equals n minus 2. And then you add 2 to both sides. And 20 is going to be the number of sides. So you got a 20 n-agon. Okay, it's a weird one, but it just works out. I think it's duododecagon. Duododecagon is a 20-sided polygon. That might be a 12-sided polygon, but I do know that it does have 20 sides. And so you actually have to solve it this way. All right, the last time we dealt with a polygon that had exterior angles, we were talking about the exterior angles of a triangle. And just to refresh our mind, this angle 1 is equal to these two angles added up. Okay, so that's the exterior angle. But this angle right here, okay, all of these exterior angles will always be adding up to 360 degrees, no matter what shape you're dealing with. So if you're dealing with the exterior angles of a quadrilateral or the exterior angles of a pentagon, okay, all of the exterior angles will always add up to 360 degrees. So you can actually find out what each exterior angle is going to be. Now, you could only do that with a regular polygon. So for example, if we were dealing with, let me see, the best way to get a regular polygon sometimes is to overdraw quite a bit. There we go. Okay, so let's say that this pentagon was regular. Okay, so I know that all those angles, and each angle is obviously going to have a vertical angle component. Okay, all these angles are the same. So if they're all the same, then all of them need to add up to 360 degrees. So I just go 5x equals 360 degrees. So I just divide by the number of sides. So 360 divided by 5, and it's, just as I suspected, 72 degrees. Okay. All right. So as long as you divide the angles, and this is only in regular polygons that you can do this, but as long as you divide by the number of sides, you can actually find the measurement of each single angle. And that's it for the polygon sum of angles theorem. If you just take your time and just work with this stuff and just be careful, just remember the exterior angles can also add up. Oh, also, here's another thing. I just forgot about this till now. I'm glad I remembered it. Since this is 72 degrees, this is a linear pair with the inside, so the interior angles are going to be 108. So each one of those angles on the inside is going to be 108. Okay. So this can also help you find the angles inside, so you can find them individually. But once again, this only works with regular polygons when you're dealing with just starting out with nothing but knowing the number of sides. Now obviously if they give you these measurements, like if they said that this was, you know, 35 degrees out here, okay, you could immediately go, oh, well, this is an interior, this is a linear pair, so this has to be what is it, 145. Okay, so you would know that angle in there. You could still do this stuff without knowing it's a regular polygon. But all I'm saying is that with a regular polygon, all you have to know is the number of sides, and you can deduce a lot about it. Okay, that's it for today. I'll talk to you guys later. Bye.